Hi everyone, welcome to Shark AI. In this tutorial, we are going to learn about the NumPy. So, when we will use the NumPy, when we will use the deep learning concepts, then NumPy will play an important role there because when you have uh, curse of dimensionality or when you have more dimensions than converting into the lower dimensions and all, in those cases, NumPy play an important role and why NumPy and why not normal array. So we'll look step by step. Also, Pandas also uses internally NumPy. So NumPy plays a crucial role in the data science or in the deep learning and machine learning techniques. So it's definitely we have to know that how the NumPy works. So we'll learn step by step. So let's start with NumPy. So what is NumPy? So NumPy is a Python library used for working with arrays. And NumPy stands for numerical Python. Okay. It has also a function for working in the domains of linear algebra, Fourier transform, matrices, and you can also use in statistics. Okay, it was invented or created in 2005, and it's a open source. Okay, why we use NumPy? So in Python we have lists, okay, but those are slow, and NumPy arrays are 50 times faster than the normal lists used in the Python. Okay, so why it is faster? Because NumPy arrays are stored at one continuous place in memory, unlike lists. So processes can access and manipulate them very efficiently. Okay, this behavior is called locality of reference in computer science. And which language the NumPy is written? NumPy is written in C. Okay, and the code base you can find in GitHub. Okay, so now we'll see how to install the NumPy. So you can use the command pip install and NumPy. Execute the cell. Since I already have it, so it's saying that requirement already satisfied. But if you don't have the NumPy, then it will install. And how to call this? So as we have already seen in pandas, it's a import NumPy, and you can also give any alias name like import NumPy as np. Okay, I executed this and you can see that the cell got executed. Okay, now let's create one array, numpy array. So suppose arr is equals to, how do we uh, write array here? To np dot array. Okay, and give here I'm giving just a numbers 2, 3, 4 and 5, and I executed this, and I just want to see how the array looks. So you can see it is printing here 1, 2, 3, 4, 5. So this is a numpy array. Okay, also you can check the version of the numpy, like uh, np dot underscore underscore version underscore underscore. Okay, and it's saying that 1.20.3. So this is my current version of the numpy. Okay, so now we will see the different dimensions of numpy array, how to create. So let's start with the 0 dimension. So if I am writing here the age equals to np dot array and any number 1. So this is actually our 0 dimension array. When you want to see the dimensions dot endim, you can see so it's saying that the a is 0 dimension array. Now the 2 dimension, 1 dimension. So if it's a b is equals to np dot array and square bracket, give any number 1, 2, 3. Okay, so this is actually our 1 dimension array. So the same way you can check here the b dimension. So it's saying that b dot endim is 1, so it is 1 dimension array. Since we have only one bracket, square bracket, and every element is inside this, So it is one dimension array. Now let's see that how to create the two dimension array. So here the np dot array. Okay, and now square bracket, just copy this one. Okay, and paste it inside this. Okay, and comma, again the same thing. Okay, so what happened, inside this bracket, this square bracket, we have two elements. This is the first element and this is the second element. So it will become a two dimension array. Okay, so if I print just the C, you can see how it is printing. Okay, uh, if I see here the C dot endim, it is saying that two dimension. You can also print that C dot shape. It's saying that 2.3, 2 into 3. So 2 rows and 3 columns. It's a kind of matrix we have. Okay. Uh, and then if I go for the 3 dimension, then np dot array. Okay, and what I'll do here, uh, it's hard to visualize, but try to understand that how this is happening. So what I'll do, I'll just give a square bracket. Inside the square bracket, I'm giving these elements, comma, again the same elements. Okay, so what happened, these are two dimensions. Okay, since we have printed this as a two dimension, so this is basically your two dimension. Okay, this is also your two dimension, and everything we are putting inside another dimension, that is here the square bracket. So square bracket, we have, this is two dimension, this is two dimension, so the whole it is as a three dimension. Okay, so D, if you see, so you can see here how it is coming. So this is actually your three dimension array, but it's really hard to visualize. But yeah, you can we can only figure out with the brackets we have. Okay, if I see here the d dot endim. Okay, d dot endim, and you can see that it's saying that it's a three dimension array we have. And if I try to shape it, you can see it's a 2 2 3. Okay, and the similar way you can create even the four dimension object. uh, if e is equals to np dot shape, np dot array. Okay, and square bracket, and inside this copy this as a whole. Okay, put this inside this, comma, and if you want to create uh, one more element, then I have given it at the three times. Okay, so if I put here e, so you can see how the e is printing. Okay, so this is the four dimension. If I write here at e dot endim, so it's saying that here we have dimension is 4. So now if we check e dot shape, and when I execute that, it's saying that 3 2 2 3. That means in three dimension object, if we have three axes, that x, y, and z, so we can see that how many elements are there in the x, how many elements are there in the y, how many elements are there in the z. But when we are talking here more than three or four dimensions, multiple dimensions, then how many elements are there in your x, how many elements are there in your y, how many elements are there in the z, and how many elements are there in the next dimension. So in the each and every dimension, it is giving you how many elements are there. Okay, in by using the shape. Okay, two dimension, it is very easy to visualize and to understand. but as you go into the higher dimension, it will be very difficult to visualize and to understand. And that is all, this is also called the curse on dimensionality, which we face very much in the machine learning and the deep learning. So uh, as we will go on, and we'll see that how to deal with this curse of dimensionality into the machine learning and the deep learning. So now let's see how the indexing works in NumPy. So suppose I have, before that, let's generate one 5 dimensions array. How to generate that? So since we have written here the manually, so suppose if we have to generate, then how do that? Then np dot array and just giving one array of 1 2 3 and 4 and comma nd min is equals to 5. Okay, and if I print this arr, so you can see that it's a 5 dimensions array. Okay, generated by the system. I have only given one array and I have just mentioned the dimensions and it is printing. And if I do this arr dot endim, it will give me the dimension. So it's a 5 dimension object. So now if I write here arr dot shape and I execute this, so you can see it's saying that how many elements are present in each dimensions. Okay, so now let's see how indexing works in NumPy array. So suppose I have array 1 is equals to np dot array and I have 4 elements inside it, 2 3 and 4. I executed this and I just want to fetch the first element of it, so it's 2. Okay, so indexing works same as the add it works in the Python. So Python arrays, so it's a 0 1 2 3. Okay, so if I print here the 3, it will give me the last element. And similar way, if I give -1, it will also give me the last element. So the negative indexes also works the same way as it works in the Python lists. Okay, suppose I have a 2 dimensions list. So okay, let's copy the whole and I have this and I have here this one. I have 5 6 7 and 8. Okay, and let's give a different name of array. So this is my array 2. Actually one bracket, square bracket we missed. So now this is 2D. Now let's array 2 and I have to 0 and 1 and it's a 2. So 0, how it happened? 0 is this one. Okay, so I have a 2 dimension object. So in the first dimension you can see that we have this and this, and the second dimension you can say that we have uh, the element of it this and element of it, that is this one. So when I am going to 0, that means I have this elements. Okay, so it will first pick this one and inside this the first one, that is the 2. And if I change this to 1, it will go to this and it will go to this, that means it will print the 6. Okay, so this is how the indexing works. The similar way it works in if you want, you can also check in the 3 dimension object. I'm just copy this one and I'm giving it here 5 9 10 11 and 12, and we have to give another bracket. Okay, let's give it to array 3. So let's check the dimension arr 3 dot endim So you can see it's a 3 dimension. So ARR 3, let's just get the first element of it, 0 0 and 0. So it's a 1, this one. Okay, and from the middle one we are going to take the 2 2 2 0 0. Let's see, because 2 is out of the bound. Okay, because in the first dimension we do not have anything in the 2. Okay, so it will definitely go to 0, and then this should also be 0 and if this can be 2 and this 2, so it is 11. Okay, 0 because we do not have anything in the 3 dimension. You can say we have only this, that is only 0 is available. If I have to give it something else, I have to give it here. Okay, for first element of 3 dimension. So the 0th is, the whole thing stands for 0, and 2 is 0 1 and 2, so it will come here, and after this the second element, so 0 1 and 2, so it's printing 11. Okay, so this is how your indexing works in NumPy array. Okay, and also negative also works in the same way. If you just want to do this -1, so it is going to the 0 2, and from here it is printing the last element, that is 12. So now we are going to see the slicing in NumPy array. So how does it syntax is start colon end colon step, the similar way as we have seen in Python. Okay, start colon end colon step. So let's see by several examples. Array is equals to np dot array. I'm just creating a 1D array, that is 1 2 3 4 and 5, and if I print ARR, okay, so this is 1D array and I just want to slice it, so I'm just writing here the print ARR. I'm taking 1 to 5. Okay, so fifth will be excluded, so this is 2 3 4 5. So 0th element is 1, first element is 2, so first element is 2, so it's starting from 2 and it is going up to 4th element. Fifth will be excluded, so this is 1 2 3 and 4. Okay, since everything we have covered, so if I just try to give it as a 4, so first element, second element, third element. Okay, so fourth will be excluded, so only the first 3 elements, not first 3, the first, second and third element are getting printed. Okay, and if I mention here the step is supposed to, when I execute so it is going up to 4 only, because it is printing first the 2 and the step is 2, that means every second element, so it is going to 2 then going to 4. So suppose if I am writing here 6 7 8 and 9 and 10. Okay, so this is my new array, and when I do this, let's see that everything I am printing, okay, 10, and when I execute this, so you can say it is going to 2, then 4, then 6, then 8, then 10. Okay, because step we have mentioned 2, and step if we mention 3, then every third element from the starting point. Okay, so you can say 2 then third, 1 2 3 fifth, 2 fifth and 8th element. Okay, so that's how the slicing works. It's the similar way Python also it works in the same way. And as you know already that if you have seen my Python videos, so ARR, and if I have to print everything from first, I'll just give this colon and everything from first will be printed. Okay, and if I have to print ARR everything up to second, then starting from first element going till the second one. So this is the way. If it is after the colon, it is blank, means starting from the first element. If after the colon blank like this, that means till the last element we are printing. Okay, now let's see the negative slicing also works in the same way. If I have to go from minus 3 to minus 1, then 8 and 9. Okay, so minus 1 to minus 3. Okay, 8 and 9. If I leave it blank, then everything will be starting from 10, 9 and 8. Okay, I have already explained all these things into my Python videos. So if you have not watched, please watch that videos first. Okay, now let's go to the slicing the 2D arrays. So if suppose this is my array, I will just copy this and create a 2D array. So let's say that this is AR, and here also let's make it till 5 and 6 to 10 bracket, so that it will be 2 dimension. Okay, so ARR, so now this is 2 dimension. Now I have to slice, so AR, okay, 1 and 1 to 4. So what does it mean is, first one, so we have two elements here in the 2D, so it will be picked from here, and in this we are starting from 1 to 4. So 1 will be this one, 7, 8 and 9 will be printed here. Okay, so this is the way of 2D slicing. So we have two elements here, first one and the second one. So we are saying that take in these two elements the first element. So we have taken the first one. This is 0th one and this is the first one. So we are taking the first one, and in the first one from first to fourth, if I change this to 0, then it will be printing from this one. Okay, 2, 3 and 4. Okay, let's take another example. AR, I'm taking 0 to 2 and second element. So it's saying that 3 and 8. So it's saying that the 0 to 2, the first one. Okay, so how many elements we have? We have here the 0th element and the first element. Okay, for better understanding, let's create another one here. Okay, 11, 12, 13, 14 and 15. Okay, so my AR is now this. So what I'm doing here, I'm just giving it as 0 to 1. Okay, and the second element of every element. So it's saying that the 3. Okay, let's do it 0 to 2. So 0 to 2 means it's starting from 0 and going till second, but excluding the second one. So 0th and first. So it is going here, the 0th and 1, and taking the second element of those arrays. So it is taking the second element. So 0, 1, 2. Here it is third and here it is eighth. Similar way, if you are defining here the 3, it will go to the every array and take the third element from here, second element from here. So look, 3, 8 and 13. Okay, so this is how the slicing works. And let's say another slicing techniques. So suppose if I have this array and I just want to get the values, those are greater than 5. Okay, so AR AR is greater than 5, and it will give me all the elements. It will loop through each array and it will return me the elements which are greater than 5. So look, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it is returning me every element those are greater than 5. Okay, another thing is, if I have to compare that, look for some elements which are already available in an array, and we were just cross checking if those are also available in the NumPy array. So suppose suppose the name is A, and A is equals to 1, 2 and 49. Okay, I executed this one. So AR, okay, np dot is in. So this is the function we have, is in, give the element that is AR. Okay, let's remove AR for better understanding, and then we'll write here. So AR, and where we are comparing with A. Okay, so now execute this. So you can see that it is comparing this AR with this A, and wherever it is true, it is saying true. Wherever it is false, it is saying false. So one is available. One is where one is available here. Where two is available here, and 49 it's not available anywhere. So it's saying that false. So, and if I have to print the values, then just do this AR and blank, and you can see 1 and 2, not 49, but this 1 and 2 values are available in this array, AR, this one. Okay, not the 49 matching values. Okay, so this is how actually our slicing works. Another things are also there, that if you want to find the np.nan values, so you can also find np dot is nan. So that is also there. If you have to find the complex, then np dot is complex. So any number is complex, then you can find using these functions. Okay, now we are going to see the array copy versus view. Okay, so copy is basically creating a new array, or you can say that if you have a numpy array and you are making a copy of it, that copy will be created into a different location. But view is actually a projection of your original array. Okay, so if any changes you are making to the original array, that will be reflected to the view array. So let's see that how both the things work. So if suppose if I have ARR is equals to np dot array, and so this is my array, and I am creating a view of it. ARR underscore view is equals to ARR dot view. Okay, and if I check now the ARR underscore view, okay, so I have the same elements as I have in ARR. So now let's insert an element at the 0th position in ARR, that is 24 or 23, and if I execute this, so now my ARR will be 23, and then 2, 3, 4, 5. So now let's see that what happened to AR underscore view. So you can see that ARR underscore view also got changed, 23, 2, 3 and 5. So this is actually basically your view. Okay, when you are changing the original array, your view will also get changed. Now let's see the copy. Okay, so ARR underscore copy is equals to ARR dot copy. Okay, we are making a copy of it, and let's see what we have in the ARR copy. So it's the same thing. Now let's change it to ARR 0 is equals to inserting element 12. Let's see the ARR. So ARR is 12, 2, 3, 4 and 5. And let's see what happened to the ARR underscore copy. Okay, so you can see it is unchanged. So ARR copy will be stored in a memory location different from ARR. Okay, so that any changes in ARR will not reflect to the changes in ARR copy. But ARR and ARR view mostly share the same memory location. When you are changing to the original array, view will also get changed. So this is the main difference between your copy and the view in NumPy. So now we'll see the how to reshape the different arrays. So I have ARR is equals to, let's say I have np dot array, and I have here 1 2 3 4 5 6 7 8 9 10 11 and 12. Okay, I'm taking 12 because it will be easy for understanding. So let's print ARR. Okay, so this is my ARR. Now I am creating an ARR1 equals to ARR dot reshape, and this ARR array has 12 elements, and I am just reshaping it 4 into 3. Okay, printing ARR1. So you can see that we are able to make it to the shape 4 into 3. It was a 1D and it is a two-dimensional array we have. So if I check ARR1 dot endIn, so you can see that we have two-dimension object here. Okay, so now we can also convert it to the any shape. So here we have 12 elements. Okay, so as long as this multiplication is 12, this reshape will be true. Suppose I have to do this ARR dot reshape, I can also make it 3 into 4, correct, because that is also 12. ARR 2. So here I have 3 rows and 4 columns, or 3 into 4 elements, and this is also the two-dimension object. Okay, I can also do this like ARR3 is equals to ARR dot reshape 6 into 2 or 2 into 6. So I'm just taking here the 6 into 2 and I'm printing here ARR3. So you can see I have reshaped it to the 6 into 2. I can also do it to the 2 into 6. So as long as this multiplication is 12, our reshape will be true. But if we try to give something which will not be a multiplication of the elements of the array, that is 12. So let's see how it says reshape. Okay, I have 12 elements and I'm just trying to do it 3 into 5, that is 15. You can see cannot reshape array of size 12 into a shape 3 into 5. So that is 12 elements, and here it is 15 elements, 3 into 5. So the reshaping is not possible here. Okay, now this is the converting it to the two-dimension object. Now creating to the 3 dimensions. So the ARR 4 is equals to ARR dot reshape and 12. So 2 into 2 into 3. So this is also 12. 2 into 4 into 3. 2 to the 4, 3, 12. So when I execute this ARR 4, so you can see that I have 3-dimensional object with the 2 elements in the first dimension, 2 elements in the second dimension, and 3 elements in the third dimension. So this reshaping is also possible. You can also write it here 3 2 2, or many combinations are possible. So this is the three-dimensional object. Okay, what you can also do, like if you don't know the dimension, so this is the most important concept. So if you don't know the third dimension, arr 5, okay, is equals to arr dot reshape, okay, arr dot reshape. So 2 3, I don't know what should be in the third dimension, so I can always give -1 if I don't know. Okay, then I just try to write here arr 5. Okay, so you can see that it has automatically taken the -1 as a 2. Okay, 1 and 2. So this -1, if you don't know what should be coming in the third dimension, you can always take it as a -1. And this, in the deep learning, we use most of the places. Okay, this is reshaping with -1, because some of the time the pixel what values will be returning, we are not sure, so we will be giving -1 in those places. Another one is changing to the flattening the array. Okay, so I have this arr 5 and I just want to make it flat. Okay, so what I can do, arr 6, let it be, and then arr 5 dot reshape, and we have to just give -1 and it will flat this array. Okay, so if I print it arr 6, so you can see that it has flattened this array. Okay, so this reshaping is a good technique, and this is the most important technique to remember. Now we'll see how to iterate over the multi-dimensional arrays. So let's say that I have an array, 2D array, that is np dot array, and let's say I have 1 2 2 3, and here I have 4 5 and 6. Okay, actually forgot to add a square bracket. So this is a two-dimensional array. We can cross check by arr dot ndim, and you can see 2, that means a two-dimensional array. So I'm just going to use a for loop. So if you have not watched the Python basic video, please do watch that video for better understanding with the for loop. So I'm just writing a for x in arr, and I am just printing the x value. Okay, so you can see that in the first time x is printing 1 2 3, and second time it's printing 4 5 6. That means in the 2D array, it's first iterating to this list, and in this list it is finding the first element as 1 2 3 and second element as 4 5 6. So it is printing both. But what if we have to iterate over every element? Then we have to use another loop for y in x. Okay, and then print y. So you can see now it's iterating over each element. Okay, now suppose I have this 3-dimension object. Okay, and I just have to loop over every element. So let's see how we can do. Let's take this one 4 5 6 and create one more element. Okay, 11 12 13 14 15 and 16. Okay, so execute this. So now this dimension is 3. Now when we'll try to do this, so you can see the first time it's iterating over the 3D and returning us 3D 2D, and it is iterating the 2D elements 1 2 3 4 5 6. So what if we have to iterate over everything? Okay, how it is like, let me show you. So if I try to print x, you can see it is now returning the 2Ds. This is 2D, 1, 2, 3 and 4, 5, 6. In the 3D, we have this first element of 2D and second element of first element of 3D and second element of 3D. Now, if I have to read again, for y in x, okay, and print y. So now inside the 2D, it is reading every element, that is 1, 2, 3, 4, 5, 6. Now I have to read every element of that 1D, that is 1, 2, 3. So for z in y, okay, and print z. So you can see now we are able to read every element of it. Okay, so this is how we have to read the n-dimensional object. So another way of doing it is using ND-iter. So how, let's say for x, not x, for I in np dot ND-iter, okay, and iterating over ARR, and I'm just printing the value of I. So you can see it is iterating over every element of that 3-dimension array. Okay, so this is another way. Another way is enumerate. So Python basics, if you have gone through, then I have explained the enumerate function. Actually not in the Python basic, but Python advanced, I have explained you how the enumerate function works. So in the same way, here we have for idx, and you can say we have j in np dot nd enumerate, and we are enumerating over ARR, and I'm just writing here the print idx and j. Okay, so it is returning with the index of it. Okay, so where that element belongs in that n-dimensional array. Okay, so this is also an example of how we can achieve this. Okay, so now we are going to see the array joinings, how to join arrays with different dimensionalities. So let's say that I have ARR1 is equals to np dot array, and I'm taking here as 1, 2, 3, 4. Another one, ARR2 is equals to np dot ARR ay, and 4, 5, 6, 7. Okay, so I have to concatenate these two arrays. So I'm concatenating on ARR. So np dot concatenate is the function, and I'm passing this that ARR1 and ARR2. Okay, and I have to concatenate. Okay, and if I print ARR, so you can see that these two array got concatenated into a 1D array. Okay, after this 1, 2, 3, 4, after this it started 4, 5, 6, 7. Okay, so this is joining 1D arrays to 1D arrays. Now let's talk about 2D arrays. So I'm taking this one, ARR3 and ARR4. I'm taking here 1, 2, okay, and 3, 4. So this is 2D array, and another 2D array is 4, 5 and 6, 7. Okay, array 3 and array 4. So what I'll do, ARR, let's say 5 is equals to np dot concatenate. Here we have ARR1 and ARR2. Okay, and we have to pass access. Okay, AXIS is equals to 1. Let's execute this. Okay, actually ARR 3 and ARR 4. Okay, and when I print ARR 5, I'll get this. So you can see this is also a two-dimensional array with the array element, so of 1 2 3 4 and 4 5 6 7. So it concatenated this and made it as a single array, and then here it is a 2D array. Okay, so another one is like adding concatenating is the stack functions. So stack is same as concatenate. The only difference is that stacking is done along a new axis. Okay, so let's see that how the stacking works. Suppose I have ARR6 is equals to, I'll just take this only. I'll just change the names. So ARR, suppose I have ARR6 and ARR7. Okay, and ARR8 is equals to np dot stack, and I have to pass here ARR6, ARR7, and axis is equals to 1. Okay, I'll just print this ARR8. So you can see that it stacked 1 4. It's a 2D array, and every element you can see 4 1 4 2 5 3 6 and 4 7. So it concatenated like this. Okay, you can change here the axis, and you can see that now it stacked along the axis. Can you see that it's also 2D, but it added like 1 2 3 4 and 4 5 6 7. Okay, and in axis 1 it added vertically. Okay, with the axis you can, we have also a function called let's say that ARR9 is equals to np dot ith stack, horizontal stack. Okay, and we have to give the arrays. Let's say we have ARR6 and ARR7. Okay, so what we are getting in ARR9 is flat array, 1D array concatenating every element of it of 6 and 7. Okay, 1 2 3 4 and 4 5 6 7. So this is horizontal stacking. Horizontal means this, vertical means this. Okay, now let's see the vertical stacking. So ARR 10 is equals to np dot vstack. Okay, and say here we have ARR, I'm using the same array 6 and 7, ARR6 and ARR7. Okay, and we'll put ARR10, sorry, ARR10. Okay, so you can see that in the vertical stacking, since these are 1D array, but it is creating a 2D array of two 1D arrays. You can see here. So this is the V stacking. Another one is like depth or the D stacking. Okay, so ARR11 is equals to np dot D stack, and I'm using here ARR same 6 and ARR7. Okay, and ARR11. Okay, so you can see it is the depth means it is going like this: 1 4 2 5 3 6 and 4 7. Okay, okay, vertical stacking, horizontal stacking. So horizontal stacking did the flattening and adding it to the 1D array. Horizontal stacking, vertical stacking is creating a 2D array with each element. Okay, and depth stacking is concatenating the same index element of the arrays 1 4 2 5 3 6 4 7. Okay, yeah, so this is all about the joining in an array. So let's see how the array split works in NumPy. So suppose I have arr is equals to np dot array, and here I have 1 2 and 2 3 4 and 5 6. Okay, 5 6. Take another one. 7 8 3. Okay, I'm executing this. Okay, one more square bracket we missed. Okay, so this is the 2D array, and I just want to see here the array. So arr split which equals to np dot array split and I'm just passing this array and how many arrays we want. So I'm saying 2 arrays we want. Okay, the whole we have 4 elements, we want 2 from each. So arr underscore split split, and you can see that it is returning 2 arrays. One is 1 2 3 4, another one is 5 6 7 8, and it returns in the array format. So you can always ask for it 0, what is the 0th one and what is the first one. Okay, so this is your array split. Suppose you have array and you want to split it into 3, then I'll just show you what it is returning. So you can see here it is returning 1 2 3 4, second one is 5 6, and third one is 7 8. So what just happened? So if the array it's not able to split equally, then it will create the arrays, or it will try to create the arrays just to balance it or just to match the number of arrays from the end of an array. Okay, so just remember that if you are passing something 3, like we have 4 elements, so we cannot divide 4 by 3, but 2 we could divide 2 into 2. So 2 arrays first it was creating, but 3 is like it is creating first 2, this is 1, this is 2, and this is 3. So if it's not able to equally divide, it will just create the arrays from the last of the given array. Okay, it will try just to match. Okay, now we'll see how this h split and v split works. So these are opposite of h stack and v stack. So suppose I have to do this h split, then I already have this arr. Okay, so h split is equals to np dot h split and arr, and how many arrays. So I'm writing here the 2. Okay, let's print this h split. So you can see how it is splitting. Horizontal split, so I have here 1 2 3 4 5 6 7 8, so it is 1 3 5 7 1 3 5 7. Okay, horizontal splitting, and 4 2 4 6 and 8. Okay, so the same way how this v split will work is v and v split. Okay, so it's 1 2 3 4, it is creating one array, and second one is 5 6 7 8. Okay, so this is v split. So this is how your splitting works. So let's see how the search works in NumPy. So suppose I have one array, np dot array, it has 1 2 3 4 5 6 and 7, these values. I just want to search what is the index where the 4 is in this array. So I'm just writing x is equals to np dot, so we have to use here where, and arr array is equals to 4. Okay, so if I see x, it is saying 3, that means at the index 3 we have this value 4. So 0 1 2 0 1 2 3. Okay, so this is 3. So suppose if I again write here 4 and again 4. Okay, let's see what it returns. So it is returning that we have 4 value at index 3 7 and 8. Okay, and another thing, so we can do like this. Another one is, suppose I have y is equals to np dot where arr divided by 2 is equals to 0. That means the numbers which are divisible by 2, what are the index of those? Okay, I am just writing y. So it's saying that the first, correct, that is the second, third, that is fourth, and so on. So it is returning it. And not divisible by 2, so it's 0, that is 1, 2 4 6. Okay, so these are the values. So now we are going to see the sorting of arrays. I mean, how to sort the arrays, NumPy arrays. So let's say that I have an array is equals to np dot array, and I have an element like 5 6 3 2 1 0. Okay, then how to sort this? Okay, then how to sort this? Then I'm just doing a sort like np dot sort and the array. Okay, so you can see that it sorted it 2 3 5 6 and 10. So this is the way how we sort the elements of an numpy array. If you have something like in the array or the array of the strings, suppose I have np dot array, just writing here c d and a. Okay, let's say that array 1, then just print array np dot sort and the array name arr1. So you can see it sorted a, c and d of these strings. Okay, now how to sort the 2D arrays? So suppose I have this here 5 6 and 3, and I have 2 10 and 1. Okay, so this is my 2D array. Now I have to sort this. So print np dot sort and the array name arr. So you can see it sorted 3 5 6, the first dimension, and the second one 1 2 and 10, the values. Okay, so this is the way of sorting it. Another thing is search sorting. Okay, search sorting is uh, to to find the element, or if we want to insert an element in such a way that the array will remain sorted. So this is called the search sorting. So let's say that I have an array that is, suppose x is equals to np dot array, and it's a 1D array like 1, I'm just keeping 2 4 5. Okay, so I just want to insert a 2 here so that my array will remain sorted. Okay, so I can do that using that. Suppose y is equals to np dot search sorted x, and I have to insert 2. Okay, so y, let's see the y. So it is returning 1. That means the at the position of index 1, that is here, I can insert this 2. Okay, by inserting 2 at the index 1, my array will remain sorted. Suppose I have to insert 5 till 5 here, I have 6. Okay, so let's execute this and see, it is saying that the fourth, that means it should be added at the last of the array so that it will remain sorted. Okay, so this is how your search sorted works. And another parameters you have, side is equals to right. From the right side also you can search. So search sorted, you can also pass the multiple values. So these things you can also see, or you can do as a task. Yeah, so now we are going to talk about the random number. So random number does not mean a different number every time. Random number means something that we cannot predict logically. Okay, so how does it work in NumPy? We'll see. So for the random, we have to import from NumPy, import random. Okay, execute the cell, and now suppose x is equals to random dot random integer, that is randint, and I'm giving here 50. So we are generating a random number uh, between 0 to 50. So if I see x 25, if I again generate this one, then it is 46. So it keep on generating some random numbers every time when you execute this random dot randint. Okay, and if you have to generate a float number, then suppose y is equals to random dot rand. Okay, and let's say y, so it will keep on generating a float number every time. Okay, and suppose you have to generate some random array. Okay, so suppose z is equals to random dot randint 100 between 0 to 100, size 5. Okay, and set. Okay, size is equals to actually 5. Yeah, so you can see that we are generating a array of size 5 from the generating the numbers from 100. Okay, so when I execute this, it got changed. When I execute this, it got changed. So every time it will create the random numbers, generating the random numbers. Okay, you can play with this size also, like 5 into 3. So when I execute this, you can see here, when I again execute this one, similar way you can execute the float values. So if I give here the value like 5, okay, you can see that we are getting an array of these numbers, these float numbers. So this is how you can generate. If you want to generate the 2D, then 5 into 3 you can give, and it will generate a 2D array. Okay, okay, and suppose you have an array. Okay, mm, let's say that ARR is equals to, I have this 1 2 3 4 and 5, and I want to generate a number from it. Okay, by choice. So let's say that I is equals to random dot choice from ARR, and I'm printing this I. So you can see that it picked this 3 randomly. When I execute this again, it is picking 1. Okay, when I execute this, it is picking 4 now. When I execute 3, when I execute again, it's 4. So it keep on selecting the new number from this array, a new element of this array randomly. Okay, so this is by choice. We are giving this array and saying select a number from this. Okay, same way you can uh, do here. Like you have array, you can give size. I just want to create an array of size 3 into 5 from this array. So in this array, element of this array will be used. So when I execute this, you can see it has only the element from this array. So this is how you can generate random numbers, or this is how the random works in NumPy. So now we are going to see the U function. So this is the last topic we are going to cover in NumPy. So what is U function? So U function stands for universal functions, and they are NumPy functions that operates on the n-dimension object. And why we use these functions? U functions are used to implement vectorization in NumPy, which is way faster than iterating over elements. Okay, so there are plenty of NumPy functions available, uh, U functions available. As you can see here, we have add, subtract, multiply, and lot of new functions inbuilt available. I'll show you that how we can use it. So let's see that I have to implement. So I have, suppose x is equals to 1 and 2, and y is equals to, suppose I have 3 and 4. Okay, and I have to use this, the inbuilt U function. So suppose print. So since add we have, okay, add, so it's not add, it's actually np dot add, and x and y. Okay, so you can say it added these values 1 and 2 and 2 and 6. So I did not give my own functions and anything, and it directly added. So because this function was already available in NumPy, okay, that's why it added. So like this we have many functions available, but yeah, you can also create your own function. Let's see that how you can create your own function in NumPy. So you have def, I'm just writing the same thing, add number, and I'm giving here the x and the y. Let's say that this is I, this is j. Okay, and return I plus j. Okay, and addition is equals to np dot from py function, the name of add number, and how many arguments, 2, and how many output, 1. Okay, and then I can write here print addition, and I can pass here 1 2 and 3 4, 3 and 4. Okay, when I executed this, it is adding this 3 and 1 and 2 and 4, so returning 4 and 6. So this is the syntax of it. Whenever you are doing, you have to add this one, np dot from py function. Okay, and then pass your function which you want to call, and how many arguments you are passing here, and how many return value you have. If I don't have it, I'll just write it ij, and I'll make it 2, and I will just execute it. Then you can see it is returning the two arrays 1 2 and 3 4, not doing anything. Okay, so this is how U function works, and there are many inbuilt functions which you can always see here in the NumPy libraries. Yeah, thank you for watching NumPy videos. Thank you.